In this video, I'm going to solder up this PCB. This is the Register PCB that I've been working towards. Now, this took me about 6 hours over time to do. I've got about 10 hours worth of video doing this. It comes from 2 camera sources, and therefore I had to edit it down to make it somewhat reasonable. And I managed to get that down to a 30-minute heavy edit. It's a little bit heavier edited than I wanted, but it took far longer to put this thing together than I was anticipating. I also lost about 2 hours of video from my digital microscope. Unfortunately, when it fills up, it starts deleting the oldest video without any warning, without any notification. It just silently chooses to do that for me. And I appreciate that. No. Anyway, I hope you enjoy. Please do me a favor, and if you want to see a redo of this, let me know. If you like how heavy this is edited, there is a lot of repetition in putting this together. But if you like this kind of a heavy edit, please let me know in the comments, because I really would like to hear some feedback on this to make sure that I'm giving you content that you enjoy. Let's get right into it. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Alright, so for these LEDs here, the one side is exposed to 5 volts. In the other side here, ground is exposed. For these LEDs here, these are driven by 5 volts, and on the other side is ground. Bottom of the T has to be right over each of these vias that goes through the pad. Let's see if I can walk these in without making a mess. Like that. So the technique I'm using at this point is to just melt the pad so that I can get the LED in place, and then melt it again so that I can actually sink it down onto the board. So for the first part, I'm holding the LED on its side, and then for the second part, I'm actually reaching up and holding it by the lens so that I can get it into its right position. Now this is stuck to the board at this point, and then that allows me to position it. So now on this side, I can now grab the solder and basically, let's get some flux on that. I keep forgetting the flux. So then it's just a matter of feeding a blob of solder in here. And those should be all fastened down. And unfortunately I did that most of that off camera. But if I look at these, look at an raking angle, they're not quite lined up, but they're not bad. Checking the solder joints on each side. Well, these I could use a little dressing here. So like D8 and D9 and D11 don't quite look right. So let's see if we can clean those up a little bit. Those actually look pretty good. Let's see if we can get D13. That actually does not look too bad. Okay, I need to remind myself how this was supposed to go together. And what I'm looking at here are the pins. So these are the ones that are going to connect off to the back plane up here on the very top. So the ones that head down, so the pins are on the top. Oh, and the bottom. Okay. Okay, so coming back to the screen here, the microscope, what that tells me is that these are the pins and these are the sockets. Next layer down, pins and sockets, and on the bottom it's sockets and then pins. So I've got to keep that in mind as I put this together. Let me grab some breadboards, and the intent here is to have the breadboards stabilize this for me while I am soldering. Okay, almost, there it is. All right, so what I'm seeing here is that everything is set in there properly. And then setting it here, then it's just a matter of soldering in those pins. I have this 0.05 inch solder. It's an older solder, but it's still good solder. But you can see the pitch of it, the size of it is much different. So I'm going to give this a shot and see if I can make this go just a smidge faster here. And maybe not. That may not be a good choice. Let's put some flux on all of that. Because this thicker solder is definitely a little harder to work with here. Okay, well, looks like I've got a solder bridge in there. Time to get the continuity tester out. Yep, it's on continuity mode. And my tests are this one and that one. No continuity. Okay, that's good. Getting other solder bridges. Maybe down here. No. And no. Alright, so I'm good there. Alright, let's move on to these. Need flux. I always forget the flux. Definitely have a solder bridge there. Cut off the used part of this. It worked. I think I'm just pushing it a little bit too fast. There's a lot of mass there that needs to warm up. Now I expected this to be very easy compared to those capacitors and resistors and diodes, and it's not quite as easy as I had thought. Oh, that's got way too much on it. But I am finding if you actually push a little bit on the contacts to make good contact, it tends to help a little bit better. Okay, let's get these and then I'll spin the board around. Oh, you know what I didn't do? I didn't put flux. I always forget the flux. Can't forget the flux, Adam. Wow, I managed to fill so many of those. That's just amazingly brilliant work there, Adam. Good God, Adam, what have you done? Okay, I think that's good. All right, so my first thought was to start with the 74 HC 138. And my challenge there is I don't have a whole lot of spares of those. So if I screw something up, I don't have a whole lot I can fall back on. So I believe I should work on the 74HC 193 counters, the up-down counters. And those counters are in these positions here on the PCB. So I'm going to give that a shot and see how we go, how it works out with that. And that should be these. And you can see right here, HC193. So I'm going to pull just one of these out. Now my problem here is identifying pin 1, number 1, and this bar here indicates which side has pin 1 on it. I believe this has to rotate. Now why I believe this has to rotate, I had a dot, or I missed putting a dot here to indicate where pin 1 was. But if you go back to KiCad, there is on the silk screen a line that extends down. And there is a cut corner here, which, well, it does indicate where pin 1 is. On the actual PCB, you can see the line on this side is short, and the line on this side extends down next to pin 1. So I believe I'm okay, at least in that regard. If I was to put that there, without all the fuzz on it, I believe that's going to be the right spot. It's just now a matter of getting it lined up. And I think that is going to be the challenge. The challenge of the day. So I think I should be able to get one pad on there and get it lined up right. Now the problem is that the way it sits, it's kind of sitting on a mound, and therefore it's trying to roll to one side or the other of that mound naturally. So that's going to be the challenge to keep the IC from doing that. Let's start with that pin there. I'm going to take, of course, my thin solder, because I'm back to small components. And let's see if I can tin this pad here. Now, if I bring this in, I think that is set. Alright, so I spin it around now. Where am I here? There I am. And then I think if I get some more flux, because I keep forgetting it. Ooh, don't do that. I should be able to tack this bottom corner here, and it's moving. That's not good. All right. So very little pressure actually causes movement, so that's good to know. I think I don't have enough solder on this pin. toward this pad. All right, let's see if I can get the other side wrapped up here. I did not put flux on that. So this is kind of a modification of the drag method, I guess you could say. So that appears to be my first IC. All right, I think I have enough confidence now I can do the HC 138. Pin 1 is down. Pin 1 is down, so I've got my orientation here that I need to deal with. Okay, so doing this with my fingers. Pin 1 is where that dot is, and so that needs to go right there on that pad. So let's see if I can get this fastened down. Okay, that's not sticking to the pad. Why is that not sticking to the pad? Let's try that again. Okay, let's try that one more time. See if I can get it to stick to the pad this time. I think that's attached. I think it's crooked. Okay, let me get the other side. Let's get some flux, because I always forget the flux. All right, let's see if I can get this way. Okay, the 74 HC 574s, there are two of those, and those go up at the top of the board. Now, the key here is that one of them is pin 1 down, one of them is pin 1 up. So I have to be cautious about that. But they should go relatively easily compared to everything else I've done. So one of them is going to be oriented like this, and one of them is going to be oriented like this. Okay, that's correct. So let's see if I can get that started here. All right, where are we at here? Only real difference here is that it's a much larger IC. Okay, that's fastened down. Then I should be able to take opposite corner and fasten that down as well. Well, that didn't work nearly as well as I hoped. And I've got a bridge connection there. All right, let's get some wick. So the last thing to do here on the top of the board is to put these last 16 ICs in. These are the 541 line drivers that need to go in to drive each of the different components. So let me get into that and get that completed here. Okay, so I did manage to get each of these marked with pin 1 with the dot, and I've got these sitting up above oriented, and I'll probably end up knocking them over at some point. But it also has the dot here marking pin 1. So this should be, well, hopefully it's just more of the same. Actually, what I'm tempted to just start with the first pin on each of these and put a blob of solder on each, and then kind of do repetition, repeating the same steps over and over so I can get a little bit of efficiency in here. A little bit of solder on the pad next to where I'm going to set this, which is going to end up raising the IC. So I will pull that out. And now it's a matter of setting in and attaching these in turn. So let's see what we got here. Get it lined up properly. And then get it lined up as best I can. Touch the pad with the soldering iron. I've got too much buildup on this tip. Let's see if I can put some solder on this to tin it. Now I flip the board around. So all of the corners I've soldered so far are this corner. And so I need to get this corner up here soldered down. And ones like this, I don't know if you can see it, this actually is lifted or twisted a little bit. So I need to come back and set those better. So for the one up here, and then I'm going to heat the pad while I'm pushing down on the IC just to make sure that it's set. And then, oops, well, that didn't work out. And on this one in particular, it's so bad. I'm going to reheat this pad just to take the tension off of it. And more of the same. As I reflow this particular pin, you can see that it actually dropped down. I'll reflow again and see if you can hear the tick. That was very soft, very faint, but I certainly felt it. So with that, then everything is fastened down, and I just need to go and solder all the different pins. Let's see if I can get that done. What I'm doing is I'm actually letting the flux pull the solder off the tip of the iron here and draw it under and around the pin, and it seems to be doing a far better job than me trying to directly solder. The key is to make sure that there's enough flux so that you can actually make that happen. So put the flux on, and literally I'm just laying the solder over the pins here and then just tapping it to melt it, and whatever pins get whatever it wants, and then I come back and I hold it to the pin, and then you can see that it's kind of being sucked around the actual pin and pad off the tip of the soldering iron. This is where I'm actually heating the pad enough to make that proper electrical connection, and that appears to do quite well, actually. Now for these two, these will be relatively easy to do because they are towards the outside. It's not a difficult spot to get to with the soldering tip. Tin the tip of the soldering iron just a little bit. And then now I just go back and heat each one in turn. And that just appears to do brilliant things with getting this IC soldered, at least from what I can tell. That technique appears to work quite well, at least for me. You know, I wonder if it wouldn't behoove me to also add flux after the first pass. And I'll try that when I flip the board around. Okay, a little bit more flux. Let's see what that does. Tin the iron again. I actually think that worked a little bit better. Okay, that's interesting. I dragged from the top of the pen down onto the pad, and that's dropping just a little bit of solder on there. And then when the pad gets heated up, it's sucking the solder kind of underneath it. All right, so flux. That's simple tin of each pad. You know, I didn't get everything, and I get that. More flux. A little bit of solder on the bottom or on the tip of the soldering iron. Set it on top of the pin and then drag it to the front. And that seems to be doing quite well in finalizing those connections. And you can see, I'm going to put a little bit more solder on the tip of the soldering iron there. You can see I missed one here. I missed another one here. And it is doing a fantastic job just getting every pin soldered down. As a matter of fact, I'm going to come back to this one and redo that one, and that actually almost looks good. Almost looks like I know what I'm doing, and I don't. I promise you. Alright, so the last thing to do here is going to be to get all the sockets installed. And then this one needs to have solder added. If I'm going to add solder, I'm going to add flux, because I'm realizing very quickly that the right amount of flux can make or break your day. And I say that because, well, in my mind I keep going back to all the home improvement shows that I watched, where when they sweated a copper joint for plumbing, the solder was able to go uphill into the joint because they used a good amount of flux on that. And that was actually the magic that actually allowed the solder to flow uphill. And I'm kind of getting the same sense here. It's the flux that is the magic that allows things to go where we want them to go. Those look reasonably good. This pin here could use more solder, and so could this one. Actually, most of these could. That's something you just don't see with a dead top-down view. Okay. So here it is. And there are some issues. First of all, the dots relating to pin 1 on each of the appropriate corners is a concern. I definitely want to get that fixed if I can, if I end up spinning this board again. On the back, again, the capacitors don't have values associated with them. The resistors don't have values associated with them. Both of those need to be fixed, and I will work on getting those again done if I have to respin this board. I'm not going to do it just for the sake of doing it. These pin sockets and this pin header, along with these two, are in the wrong position. The sockets are supposed to be up here where the rectangle is, and the pins are supposed to be down here. If you look up here, the rectangle is around the sockets, and the pins are where there is no rectangle, and that's the way it should be down here. These are in the wrong spot, so I'm going to have to actually disassemble these and get them inserted properly. Now that's going to be a little interesting to accomplish without destroying either the pins, because the pins are expensive, or the sockets, because the sockets are expensive. But I don't want to destroy the board either, because I really do want to try to preserve and have all 20 of them. I don't want to have to go back and reorder another run of this if I don't need to. Okay, so obviously I need to fix the sockets and pin headers, and I'm going to go ahead and do that in the next video. At the same time, I do want to update the PCB design in KiCad. Just in case I do have to respin this board for any reason, I want to make sure that I have a better quality product at the other end of that. I do need to work on some CMOS and TTL integration, and I'm wondering if I will put together some PCBs to help me with that. It's likely I will, just to make things a little bit easier and a little bit more stable. And I've got some 19 more of these Register PCBs to solder up, and I'm procrastinating on that a little bit, simply because I don't want to get all the way down the line, solder them all up, have them all completed, and then realize I have to actually redo it. And the components for this were not trivial to acquire, so I'm going to try to drag my feet as long as I can with those. I also need to create the buses, and there are 6 buses in this computer. I need to start being able to plug these registers into those 6 buses. Well, 5 of the 6, one of them is not touched by the registers. Those are going to be done on strip prototype board. And then I need to actually start producing some memory and memory fetches associated with a program counter. And so I'm going to start working up some ROM as a temporary memory. So I've got some EEPROM here from other projects I'm going to repurpose and start putting some information on there that we can then turn around and use for testing. And then I've got to make a temporary board for that. I'm going to do that on a breadboard. I've got an assembler from a previous project, and if I can, I'll link in the cards up here. I'll definitely put it in the description. A link to James Sharman's assembler. It looks very similar to what he presented in his videos. I went ahead and wrote my own based on the things that he described. I have not seen his code. I don't know how close our implementations are. But I do have something that functions, it has the same hallmarks that his does. I took a lot of his creative design and created my own implementation of it. And then I'm going to define the assembly language mnemonics like move and add and what those are going to start being. That's a little bit down the road, but we need to start putting a baseline together for several of these. I still have to do or want to do a KiCad design for the clock module, but since it's a temporary clock module, am I really going to have an effective use of my time to do that? Maybe, maybe not. It would be practice more than anything. And then I do need to add a line driver to the test harness. Thank you. We'll see you soon.